السلام ورحمة الله وبركاته.
كل عام وانتم بخير يا شباب. أهله الله علينا وعليكم بالخير والعافية إن شاء الله والرضا والقبول. Today inshallah we have a new section. If we can consider it a new indeed, it is just a review and a summary of the previous sections. 11.7. We will not learn a new thing here in this section, new techniques or new tests, but we are going to learn a new the whole strategy. We will try to build up a strategy for testing the convergence and divergence of series. Please, ya shabab, pay attention because what we are going to say is important and it will help you a lot, of course. It will help you a lot to test the convergence and divergence of series. It will save your time as well. So let's start with refreshing your memory about the sections that we have studied from 11.2 up to 11.6. So in the first section, which is our 11.1, we have defined the series, what we mean by series, and what is the convergence, what we mean by the convergence and divergence of a series. So when you have infinite series, if you can have a formula for the nth partial sum, and the limit of the nth partial sum exists as a finite number, then the series is convergent and its sum will be that number. But of course, the problem that we cannot always find this one. We can find it only for a few series like the geometric series, the telescoping series. Now, the geometric series is one of the most important type of series. It has another form starting from 0. Notice here, Shabab, that the power, the index n is in the power. So A and R here are constants free from n. If the absolute value, طبعا A is the first term. How to know what is A? A is the first term. What is R? R is the common ratio between these terms of the series. If the absolute value of the common ratio is less than 1, then the series is convergent. Otherwise, it is divergent. What is good about the geometric series, that if it is convergent, you can find its sum. Its sum is the first term over 1 minus the common ratio. طبعا, if the absolute value of the common ratio is greater than or equals to 1, the geometric series is divergent. We have studied also the harmonic series. We will call it later the harmonic P series. It is divergent. Also the telescoping, ya shabab, if you remember example number 7 in this section in 11.2. When you have a series of the difference and there will be a cancellation, telescoping sum at the end. طبعا, usually also when you have len functions like len, like tan inverse, like polynomials that can be solved by partial fractions simplified. Please refine this. This is a very important type of series. What is good about the convergent series? If the series is convergent, then the limit of the nth term is 0. But if the limit of the nth term is 0, it doesn't mean that it is convergent. So be careful. This is an example about that. The limit is 0, but it is divergent. So be careful. What is true is this. If the limit is not 0 or does not exist, then it is divergent. And this is, by the way, one of the most important tests that you need to recall and to use. Test for divergence. You can call it the divergence test. Test for divergence or the test divergence. And as I told you in some textbook, they call it the nth term test for divergence. If you have two convergent series, you can add them, you can subtract them, you can multiply by a constant. By the way, multiplying by a constant, سواء كانت convergent or divergent, it will not affect. It will stay convergent or stay divergent. What else? In 11.3, we have the integral test. Simply, it says if the nth term equals to the value of the function at n, where f is a continuous, positive, decreasing function. You have to check these 3 conditions to be able to apply the integral test. If the integral is convergent, then the series is convergent. If it is divergent, the series is divergent. Be careful, even if it is convergent, the sum of the series does not equals to the value of the integral. Be careful about that. One of the most important results or consequences of the integral test is the P series, which is this one. It is convergent if P greater than 1, divergent otherwise. In 11.4, we have the comparison tests. Mainly, we have two comparison tests. But be careful here. When you want to use the comparison tests, you are only able to use them with positive terms, if the series is with positive terms. طبعا, if you have a series with negative terms, you can study the convergence of the absolute value. And you will see the absolute convergence in that case, as we did in 11.6. So what is the comparison test? The direct, let's start with the direct one. We call it shortly the CT or the DCT. So if you have AN less than BN, if the bigger one is convergent, then the smaller one is convergent. So what does that mean? If your series is less than a convergent series, then it is convergent. But if it is less than a divergent, no conclusion. The other part is this. If AN less than BN and AN is divergent, the smaller one, then the bigger one is also divergent. So if your series is bigger than divergent, then it is divergent. Otherwise, no conclusion. So to avoid this headache, use the limit comparison test. There is no need to compare there. Just you need to find the limit of the ratio. Take the nth term over the nth term. If the limit is equals to a positive finite number, then both converge or both diverge. If limit is zero, this is what I called the general limit test. I add the two cases that it is 0 or infinity. طبعا, this is exercise يا شباب in your textbook. I have added for you here and called it the general limit comparison test. So if the limit is 0, you need additional condition. The additional condition is the series that its nth term in the denominator, it is convergent. Then the one that its nth term in the numerator, it is also convergent. If it is divergent here, no conclusion. If the limit is infinity, and the one in the denominator, it is divergent, then the one that its nth term in the numerator, it is also divergent. If it is here convergent, no conclusion. In 11.5, we studied the series that they are alternating when we have positive, negative, positive, negative. All what you need to check that the term without the sign, this term, the positive term, this is positive, that it is decreasing and it decreased to 0. So if it decreases to 0, then it is convergent. This is the only section that you have estimation in. So this series says if you have a convergent alternating series, its sum is S, then the difference between S and the approximated nth partial sum, it will be always less than Bn plus 1. Usually we call this the absolute value of the error is less than this. The last section that we had, ya shabab, it was 11.6. I'm just trying now to refresh your memory. Please pay attention. So absolute here, this section is about absolute convergence and conditional convergence. Now here, when you have a series that might be with positive terms or negative terms or whatever, you need to look at the series of the absolute values. If the series of the absolute values is convergent, let's say, if we find that this is convergent, if this one convergent, then the original one will be absolutely convergent. So this is the meaning of the absolute convergence. Lakin if this is divergent, if the series of the absolute values is divergent, it doesn't mean that the original one divergent. You need to check the original one. Now you have two cases. If this is divergent and the original one divergent, then it is divergent clearly. Khalas, it is divergent. So if the original one is divergent from the beginning, no need to do anything. But if the original one, if this is divergent and the original one convergent, like a P series, then we call it conditionally convergent. So what is the conditional convergence? If the series is convergent, but not absolutely. So this means that this one is convergent, but its absolute value, the series of the absolute value, this is convergent, but this one is divergent. This is the meaning of the conditional convergence. طبعا يا شباب, if you have a series with an is positive, the terms are positive. In this case, an is the same as the absolute value. And in this case, no need to talk about conditional convergence because we have the same, it is the same series. They are not different series. Every absolutely convergent is convergent. And this is why it is good if you can decide about the absolute convergence. Even if he asks you about the convergence, find the absolute convergence, study the absolute convergence. The most important test to decide about the absolute convergence is the ratio and the root test. In the ratio test, just find the limit of the absolute value of an plus 1 over an. And in the root test, find the limit of the nth root of the absolute value of the nth term. If the limit is L, if L is less than 1, greater than or equal 0, then it is absolutely convergent and therefore convergent. If the limit is greater than 1 or infinity, it is divergent. If the limit is 1, the test fails, no conclusion. Now, Shabab, let's start. Please go over this strategy word by word, line by line. Please, Shabab, wake up and follow me because I will ask you at the end. So, what is the strategy, Shabab? Let's read it because I'm afraid that some of you, they are not reading. If it is not wise to apply a list of tests in specific order until we finally work, until we find the one test that finally works. That would be a waste of time and effort. So it is not practical to go over all the tests until you have one of them. So instead of that, we will do as we did for integrals in chapter 7, if you remember. So what is the main strategy, ya Shabab? Who can tell me what is the main strategy? It is classifying the series. It is like the integral also. Classify your series according to its form. To help you do that, I will show you here some hints. If the series is of this form, then it is B series, which converge if B greater than 1, diverge otherwise. If it is this form or this form, it is geometric, and it converge if the absolute value of R less than 1, diverge otherwise. طبعا usually يا شباب, this will not be clearly given for you. So you need to do some preliminary algebraic manipulation to simplify it. You need to simplify, do some algebra to have it in that form. If the series, it is similar to a P series, not exactly a P series or a geometric series, but it is similar to, like what, for example, like this one. This is not a geometric, this is not a P series, but it is similar to B series. You can compare it with, it will be less than this one. Compare it, you can compare it with a B series. The geometric series that is similar to, but not exactly, like this one, for example, 1 plus 2 to the power 2 to the power n. This is not a geometric series, but you can compare it to this geometric series. And when you compare, be careful, ya Shabab, in particular, if the nth term is a rational function or algebraic function. Rational function means polynomial over polynomial. Algebraic means square root over any algebraic function over algebraic function. Then if it involves, what we mean by algebraic function, it involves roots of polynomials. Then the series should be compared with P series. This is very important one. If you have a rational function or algebraic function, compare it with a P series. Notice that most of the series in section 11.4 Shabab are of this type. The question is how to find the one that you will compare with. The idea is to keep only the highest power in the numerator and the highest power in the denominator. So the dominant terms with the dominant term. We will have an example that shows this. So be careful also, Shabab. The comparison tests apply only to series with positive terms. Don't use it if the terms are not positive. But of course, if it has some negative terms, you can work on the absolute convergence. See the absolute convergence. You will be lucky if you find that it is convergent, then the original one will be absolutely. Now, if it is divergent, the first one might diverge, might converge. You need to check. Okay, this is also so important. I advise you to do this at the beginning. to be number one. If you can see at a glance, by at a glance here means without long calculations, just easily, if you can realize easily that the limit of the nth term is not zero, then the test, the series is divergent by the test of divergence. But if the limit is zero, no conclusion. You can, it might converge, it might diverge. If the series is alternating, use the ideas of 11.5, the alternating series test. If the series involves factorials, like n factorial, or other products involving a constant raised to nth power, then it is very convenient to think about the ratio test. Be careful, ya shabab, here. If you have B series or rational function or algebraic function, if you take the ratio test, the limit of the ratio will be 1. Check that. So do not use the ratio test when you have P series or similar to B series or rational functions or algebraic functions of n. In that case, the limit will be 1 and the test fails. Try it, ya shabab. So this will save your time, of course, if you know that. Now, if the nth term is something to the power n, then use the root test. If your nth term is equals to f of n, where f of n here, where f is a real valued function that is easily integrated, you can easily find the integral. If the integral is complicated, avoid doing this. But of course, ya shabab, you can use the integral test, but don't forget to check that the conditions, the hypotheses of this test are valid. Continuous, positive, and decreasing function. Here we have some examples that may be useful for you, shabab, to do. So we will not go over them with details, but just to give you the idea. Let's start with the first one. Who can tell me, shabab, what do you think about this series?
Divergent.
Why, Abdurrahman, it is divergent?
Because the limit nth term, it's half, not zero.
Allah yarda alayk, Abdurrahman. Let me just write here. What is your serial number, Abdurrahman?
28.
28, Abdurrahman al-Fihayl. Ahsanti, Abdurrahman. So, ya shabab, here, look at the nth term. Look at a glance at the nth term. The limit of the nth term is 1 over 2. The leading coefficient over leading coefficient. So, it is not zero. So, divergent. The series is divergent by the test for divergence. If the limit is 0, it might converge, it might converge. We have no decision. Great. What about this one, ya shabab? What about this one? Classify it. What you can say about it? Is it rational or algebraic? It is algebraic function, ya shabab. It is algebraic function that you have a radical root over a polynomial. Mansour, what do you want to say?
We compare it with the B series.
Which B series we will compare with, ya Mansour?
Square root of n to the power 3 over 3n to the power 3.
Why? Why this one?
Because
the highest power, the dominant term, so we will ignore the smaller. We just focus on the bigger one here and here, and we will ignore the others. But we will not cancel them here. We will compare it with this. You are right, Mansour. Excellent. Walid, do you have another idea other than what Mansour said?
No.
Okay. So here, since the nth term is algebraic function of n, then we compare it with the given B series. What is the one that we will compare with? We will compare it, as we said, with cubic root of n to the power 3, the square root, not the cubic root, the square root of n to the power 3 over 3 to the power n to the power 3. Now simplify. This is 3 over 2, and this is 3 over 2. Now this will be 3 to the power 3 minus negative 3 over 2 in the denominator, so it will be in the denominator. Now you will compare this with this. And this one is ya shabab, you can take the third out, and this will be 1 over n to the power 3 over 2. And let me ask ya shabab here, let me ask Ali al-Eid. Ya Ali, what do you know about this series?
It's a B series.
It is a P series, you are right. Convergent or divergent?
Convergent because it's greater than 1.
الله يرضى عليك يا علي. أحسنت. You are right. ما شاء الله عليك. Yes. I have missed you يا علي since I didn't hear from you since long time. Why you are not participating يا علي?
Yeah.
I have checked that you didn't participate too much, so be careful, try to participate. Now,
Okay.
what about this one, ya shabab? Now we have here. Yes, ya Walid, what do you want?
We can use the integral test.
Let me, before this, I forgot to mention something here because I was so happy to hear from Ali Al-Eid. I forgot to ask you which test you will use now. You can hear this is you will compare this with this by the comparison test, the direct one or the limit one.
The direct.
No.
Because
Try to do the direct. Try to do the direct. It will. You have how to make sure which one is bigger, this one or this one. Which one is bigger?
The one over n3/2 maybe because the.
Not maybe. Not maybe. You have to be 100% sure.
Yeah, because the denominator is less than.
If you are going to use this in the quiz, you have to show me why this is less than this or this is greater than this. You have to show me, and it is not easy. So I advise you, Ya Ali, to use the limit. The limit, not the direct. What is the limit? What you need to do in the limit comparison test? Just bring this one. Bring
over
this
that one.
Here. Over that one here.
Yeah.
And you should have a positive number here. You should have a number
positive finite number, yeah.
Greater than 0. Both converge or both diverge. But if you get infinity, it's okay, by the way. If you get infinity and the one in the denominator it is divergent, then the one in the denominator is also divergent. Look at the general limit comparison test. Okay, yeah, Walid, what you said about this?
We can use the integral test.
Why you jump to the integral test?
Because it's easy to evaluate it.
Maybe you are right. So look at this integral. Is this integral? This is the first thing that you should ask yourself. Can I evaluate this integral or not? طبعا clearly يا شباب that this is, of course, let me forget about the limits now so far. This is e to the power t, where t here is negative x squared. And what you will have here, it will be negative 1 over 2 dt. And of course, this is so easy integral, okay? And of course, you can return it back to e to the power negative x squared. And this will be from 1 to infinity. And you need to consider it as an improper integral. But Walid, you need to check that it is what?
Continuous.
Positive, continuous, decreasing. And you have to show me this in the quiz if you are going to use them. Okay? So be careful. If you can find a test other than the integral test, do. But if you don't, it's okay. What do you think? Can we use another test, ya shabab? Who has another idea about another test? So here you need to use the integral test, but also you can use the ratio test, by the way. The ratio test works here also, ya shabab. Check that, please. What about this one, ya shabab? Please, other than Mansour and Sufyan and Walid, Muhannad by Ismail, yes.
I have a question, not a...
What is your question? Quickly, Muhannad.
In example 3, can we use the nth term test?
What is the limit of the nth term test? What is the limit of n e to the power negative n squared? It is 0.
Yes.
So, if the limit of the nth term is 0, so what?
It converges.
مين قال كذا يا مهند؟ اعطيني في أي section قلنا هذا الكلام.
ماني متأكد عشان كذا سألت دكتور.
No. If it is convergent, the limit will be 0. But if the limit is 0, it might converge, it might diverge. اتذكر الهارمونيك يا مهند. مش هذه divergent ولا لا؟
صحيح.
وإيش الليمت حقت الانث تيرم؟
0.
So وهاي مثلا وهاي convergent والليمت حقت الانث تيرم 0. But it is not the case. It is only if it is not zero. If it is not zero, then it is, of course, we can say that it is divergent or convergent if it is not zero or does not exist. Ali, what do you want, Ali? Please, ya shabab, if you have questions, yes, you can keep them to the end. Yes, ya Ali.
No, for example 4.
You have an answer for example number 4. Yes, ya Ali. What is it?
Which use the alternating series test.
The alternating series test. You need to check that this is decreasing. This is the n. You need to check that it is decreasing and it decreased to 0. And you can show that it is not difficult. You are right. So this one, it is alternating. So it is convergent. Check that. It is convergent by the alternating series test. Okay. So this one, the whole one is convergent by the alternating series test. Check. Now, what about if he asks you to decide about if it is absolutely convergent or not? If you want to know that it is absolutely convergent or not, you need to find the series of the absolute value of this term, which will be the series of n to the power 3 over n to the power 4 plus 1. Now, this is a series with positive terms. Now, is it convergent or divergent, Shabab? What do you think? Which test we can use?
Divergent, I think.
By what test?
I take the dominant term.
So by the comparison test, you mean? So this one, you will compare it with this one. N to the power 3 over n to the power 4, which is sigma 1 over to the power n. Now you will compare this with this. So don't use the direct. If you know which one is smaller, which one is bigger, it's okay. But use the limit comparison test. And by the limit comparison test, ya shabab, the limit will be 1. Check that. The limit of this one over this one will be equals to 1. So both converge and both diverge. So this one is divergent. So the original one will be divergent. So this is divergent, ya shabab. So what will be the final decision about this one?
Conditionally,
it is convergent, but the series of the absolute value is divergent. So it is conditionally convergent. You are right. You are right. Great. But if he just asks you about the convergence, khalas, the alternating series test is enough. But if you want to know if it's converged absolutely or not, you can use the absolute terms. Now, example number 5, ya shabab. Example number 5.
Maybe ratio test.
مين قال the ratio test؟
علي.
علي الصانع. أحسنت يا علي. كم السيريال نمبر يا علي؟
I think 16.
16. Excellent, ya Ali. Why you thought about the ratio test?
But factorial. Okay, factorial.
Because of the factorial, yes. Because of the factorial, we will use the ratio test. And you can decide from there if it is convergent or divergent, it depends. What about the last one, Shabab? Muhammad Al-Yami?
A comparison test.
With who? With which one? You are right. You are right. By the comparison test, you are right. Comparison test with what?
1 over 3 to the power of n.
You are right. This is similar to geometric series. You know, ya shabab, that 3 to the power n, if you add 2, it is greater than 3 to the power n. If you take the reciprocal, it will be. So you can use the direct. You can direct compare this one with this one. But you need it works if this one is convergent. Now, what is this series? What is this series now? The question is, what is this series? What is this series? Let me ask someone to help me with that.
It's geometric.
No. Hello, Muhammad Halabi. What is this series, ya Muhammad? Muhammad Halabi, are you here? Muhammad is not here. He's not responding. Muhammad by Ismail, he is already responded. Yeah, Jawad. Let me ask Jawad. Jawad, what is this series? Yeah, Jawad.
Yes, sorry, there are some more things.
Jawad.
Yes, doctor.
There is a noise. I cannot hear you.
من عمال دكتور عمال موجودين في البيت.
Okay. Jawad, he didn't answer. Yasser al-Qahtani. Yasser.
Yes, doctor.
Yes, Yasser. What is this series?
Geometric.
Good. It is geometric. Convergent or divergent? Convergent or divergent? Geometric series. What is A? What is A? What is R? If it is geometric series, tell me what is A, what is R?
R should be
to infinity.
R should be less than 1.
What is R?
It's here.
What is A? A is easier, yeah, sir. A is very easy.
A is 3.
3? No. This one, if you want to write it as a geometric series, write it this way. You can write it this way, but it is better to write it this way.
1/3.
1/3. A is the first term. When n is 1, it will be 1/3. This is A. So here we are. What is R, Yasser? Quickly, Yasser, please. It is also third. Take the ratio between the terms. Just find a few terms at the beginning. Please, ya shabab, please wake up, pay attention. So now this is a convergent. Now our series is less than a convergent, so it will be convergent. By the way, if this is divergent, we have no conclusion. But we are lucky because this one is convergent and this one is less than a convergent, it will be convergent. We have a shabab here, you have many suggested problems and we have 4 recitation exercises. But also we have here like 38 exercises from section 11.7. I want you to practice, shabab, and to solve as many as you can. Yes, I heard someone wanted to ask.
آخر example ممكن تطلع له لحظة بس.
Okay.
دحين نستخدم القانون واحد على A negative R ولا كيف؟
This is if you want to find the sum. If you want to find this one. If you want to find the sum, you can find that one. You need to revise. Here we are just about the convergence and divergence. We compare that one with that one.
Not the sum.
Let's see, ya shabab, now get ready to solve the recitation exercises. What I will do, ya shabab, I will send you to 2 or 3 minutes. They are enough for you to solve one, to study the convergence and divergence of one of these. Okay, so I will divide you into 4 rooms. There will be like 10 students in each room. So please solve, if you are in room number 1, take a photo, ya shabab, of this. If you are in room number 1, solve question number 1. If you are in room 2, room 3, take a photo, screenshot for this. And please try to, when you come back, I will ask you, shabab, about if it is convergent or divergent, and absolutely or conditionally or divergent, which test you used, you compared with what, and so on. So I will now create the rooms, shabab, for you. Please be quick and everyone should understand. I will ask anyone from the group. Bismillah. See you, shabab, after 3 minutes from now. Let's say from 3 to 5 minutes at most. عبد العزيز الخطيب, عبد اللطيف الملحم, علي القحطاني, مهند حلبي, where are you? What you are doing? Why you didn't join a room? شهاب, مهند حلبي, علي القحطاني, عبد اللطيف الملحم, عبد العزيز الخطيب. Guys, you are not responding. You will be recorded as absent. The last call: عبد العزيز الخطيب، لطيف الملحم، علي القحطاني، مهند حلبي. Who is absent? No response. No response. Who is not response? عبد اللطيف الملحم and مهند حلبي. Welcome back يا شباب. Now in 2 minutes for each group. We need to see what you have done so far. Okay, Abdulaziz Al-Wahabi, group number 1. Convergent or divergent?
Convergent.
By which test?
First take at the end we will use geometric. في البداية بناخذ الابسولوت value.
By which test?
الابسولوت value يا دكتور.
في تيست اسمه الابسولوت value؟
لا اللي هو نسيت اسمه مشكلة.
The absolute convergence. You will study the absolute convergence with which test? By you said convergent. By which test? The absolute value, the series of the absolute values. So you used the series of the absolute values. Okay. This one. Is this what you are talking about? The absolute value of sine 2n over the absolute value of this is the same because it is positive. Now this one, you said it is convergent or divergent by which test? عبد العزيز الخطيب. عبد العزيز الخطيب.
Yes, doctor.
By which test? عبد العزيز الوهيبي said it is convergent. By which test? ما عندنا وقت يا عبد العزيز لو سمحت.
I don't know.
بدر قعد. بدر.
Yes, doctor.
By which test?
Comparison.
With what?
With 1 over 2n.
الله يرضى عليك يا بدر. أحسنت. حضرهم الطلاب اللي يشرح الصدر. الله يرضى عليك يا بدر.
إن شاء الله.
قاعدين نسوي يعني. Your grades يا شباب will be rechecked. For every student he deserves a grade that he didn't deserve, he will not get it. Believe me, you will get only what you deserve. Okay, now by the comparison test, why you thought يا شباب about the comparison test? Unfortunately, I don't have much time to compare, but you know that sine 2n is less than 1, the absolute value is less than 1. And of course, if it is not even 1 because we cannot have here 2 pi or pi over 2. So if you divide both sides by 1 plus 2 to the power n, this will be less than this. So we wish that this is convergent. If this is convergent, this series is convergent, we will. So indeed, this also is less than 2 to the power n. So we will compare this one. This one is less than 1 over 2 to the power n. And this one is what is this? يا عبد العزيز الملحم. عبد العزيز الملحم. What is this series? عبد العزيز الملحم. This series is what? عبد العزيز. No respond. طبعا يا شباب عبد اللطيف الملحم and مهند حلبي, they didn't join any room, so they are considered as absent. And also I'm asking now عبد العزيز الملحم and he is not responding. Okay, عبد الله الصايغ. عبد الله الصايغ. What is this series? What is this يا عبد الله?
هذه
This, yes.
1 over NP كانت.
What is this?
1 ايش يا دكتور؟
هاي series هاي. This one. What is it? What is it يا بدر الحبوبي?
It's a geometric series.
It is a geometric convergent or divergent?
This one is divergent.
Divergent. Why it is divergent?
It's because we start from 1.
Then start from 1 to infinity to the power n. So you can write it as sigma n start from 1 to infinity 1 over 2 times 1 over 2 to the power n minus 1. So the first term is a is a half and r is a half. So are you still saying that it is divergent?
Oh no, it's it's convergent.
So be careful, please, ya Badr. Yes. Now this is a convergent one. So this is convergent. So this series is absolutely convergent. This is convergent طبعا because it is positive terms. Now the original one will be what? Will be absolutely not only convergent. Indeed, it is absolutely convergent by the comparison test with this series. Okay, now what about room number 2? Room number 2 يا شباب. يلا تركي الجعيد. Yeah, Turkey, what you have decided about this series, is it convergent or divergent? Turkey.
Yes, doctor.
Convergent or divergent يا Turkey?
Our group thinks it's divergent, and we use the limit comparison test.
Good. The limit comparison test, which means that it is the limit of tan 1 over n when n goes to infinity. What is this equals to?
This equals to 0.
0. So because it is equals to 0, it is divergent?
No, in this case, it's undecided.
No conclusion here.
Yeah.
We don't know. But by the way, this limit is 0, but you have to be careful about evaluating this limit. It's not easy because tan here is not, of course, a continuous function. You know that. But of course, here we will not have that vertical asymptote. So it's okay. The limit is 0. And here, because n cannot be, of course, here the vertical asymptotes of tan. So here, no conclusion, ya shabab. This is not the case, ya Turkey. Allah yarda alik. Abdul Aziz al-Jaid. Let's take another Jaid. Abdul Aziz al-Jaid. This is diverged by which test? Abdul Aziz. Yeah, Abdul Aziz, you are muted.
Yes, doctor. Can you hear me?
It is, you said in the group that it is divergent. By which test? Anyone, Shabab, from room number 2, please?
Yes, doctor.
Yes, Walid. Who said
Ali?
Ali. Yes, Ali.
It diverges by limit conversion test.
By the limit conversion test with who?
With b equal 1 over n.
With 1 over n. With this one.
Yeah.
You are right. Allah yarda alayk ya Ali. Allah yarda alayk wa yarham walidayk. Look, ya Shabab, here we have by the limit conversion test, what is the limit of tan 1 over n over 1 over n when n goes to infinity?
It will be 0. It's 0 over 0, so we can do L'Hopital rule.
You can use L'Hopital rule, but it is easier than that, ya Shabab. This is just limit t goes to n, both this equals to t. Now when n goes to infinity, t, which is 1 over n, goes to 0. So this will be tan t over t, and the limit of tan t over t, ya Shabab, when t goes to 0 is what?
1.
This is 1, math 101, ya Shabab. You can use the L'Hopital if you want, but it is 1. It is clearly 1. Okay, room number 3. Room number 3, Usama Wakid. Usama, what do you decide about this one, convergent or divergent? Usama, we cannot hear you.
Divergent. We used in our group. Hello? أيوة. By the limit conversion test.
By the limit conversion test with what? You compare it with what?
1 over n.
With 1 over n. Do you agree with him, Shabab, in the room? Muhammad al-Nasir, do you agree with him? Ilyas, Mshari, are you agree with him? Do you agree with him?
I don't know the name of the test, but I know how we solve it. I don't remember.
It is divergent.
Divergent test.
Divergent
test.
So it is not by the limit comparison test. Be careful. What you did is not correct, ya Osama. It is not by the limit comparison test. It is divergent by the test for divergence. If you look at this and calculate the limit when n goes to infinity for the nth term, you see that it is limit n goes to infinity for sine 1 over n over 1 over n. Just write this n in the denominator. Now, again, as I did for you, Shabab, before in the slide, in the previous slide, this is sine t over t when t goes to 0. And this is equals to 1. So, because it is 1, it is not 0. So, by the test for divergence, it is divergent. You need a lot of work, ya Shabab. Last group.
معلش يا دكتور أنا من روم 2 مو روم 3.
We don't have time, ya Shabab. Group number 4, Abdurrahman al-Juwaid. Abdurrahman, please. What you have decided, Abdurrahman, convergent or divergent?
Divergent.
By which test?
The root test.
Allah yarda alayk, Abdurrahman. Ahsant. It is divergent by the root test. Excellent, ya Shabab. Abdullah Sayer, can you help me to apply the root test? This will be n goes to infinity for the nth root of the absolute value of the nth term This will be limit n goes to infinity. This is the nth root, ya shabab. And the absolute value here, this is an. Indeed, it is positive, no need for the absolute value. So it is n factorial all to the power n to the power 4n. Now this equals to what? The n will be cancelled with n. You will have n factorial, the limit. We still have the limit. When n goes to infinity, I will just take one additional minute from your valuable time, n factorial over n to the power 4. Is that right? Now,
Yeah.
what is limit equals to, Shabab?
Infinity.
This equals to what?
Infinity.
Why? How can you show that it is infinity? You are right.
Because
right.
the factorial increases faster than.
You are right. The factorial increase faster than this one. But how can you show it algebraically? I can show it for you, Shabab, algebraically. Look, what you can do, n factorial is, look here, n to the power 4. We have n. This is n to the power 4. So n factorial means n times n minus 1 times n minus 2 times n minus 3. So 1, 2, 3, 4 n's. Now what is remaining is n minus 4 factorial. Now the limit of this part, Shabab, is what? Polynomial of degree 4 over polynomial of degree 4. The leading coefficient here is 1. The leading coefficient here is 1. And here you have the limit of n minus 4 factorial. When n goes to infinity, this goes to infinity. So this will be 1 times infinity. It is infinity. All right. So because of that, it is divergent by the root test. Thank you, Shabab, and see you inshallah on Thursday. I'll still stay here, Shabab, if you